MCP servers, there's a few super useful ones and some more fun because we can ones. There's also still a few UX issues that need to be worked out, like discovery, random UVX and NPX commands, per client setup, hard-coded secrets, and many security issues. Well, it doesn't have to be this way. Docker have actually solved this. Check out MCP Toolkit. You can enable this in Docker Desktop as an extension, and once you do, the MCP catalog is your centralized hub to browse hundreds of trusted MCP servers, all verified by the Docker team. That's discovery sorted already. Hit that subscribe button to discover more of our videos. All we need to do now is, inside of the catalog, find the MCP servers that you want to turn on, and just hit the switch. It really is that simple. But what about using these with our clients? For that, just go to the MCP Clients tab, find Cursor or Claude, and hit Connect. If your client isn't supported here like Claude Code, we can add it manually to the mcp.json with the following command. But good news, we only have to do that once. Afterwards, any MCP servers we add will be connected under the Docker MCP server. It's almost like an MCP gateway. Now all we need to do in our client of choice is just use the MCP servers like normal. Any new server I activate from the catalog should be picked up for you, or you might have to perform a client refresh, but at least you haven't had to go digging in the JSON file and messing with dependencies. Gone are the days of those random UVX and NPX commands and per client configuration. But how does this solve security? First, when we add an MCP server like the GitHub one that needs some secrets, it will ask up front the secrets that it needs, and it will use secure credential storage to hold these. It also has OAuth support when that's needed as well. So gone are the days of storing your environment variables in an mcp.json and hoping that no one finds it. But it goes beyond credentials. When actually running these MCP servers and tools, Docker does something quite unique. Security at runtime is enforced through resource and access limitations. The MCP tools actually run in their own container and are restricted to 1 CPU and 2 GB of memory, limiting the impact of potential misuse on computing resources. It's not the MCP server in a container, it is each tool call. That is some really cool infrastructure. The MCP servers also have no access to the host file system, unless, like containers, you explicitly select the servers that will be granted file mounts. Finally, requests to and from tools that contain sensitive information, such as secrets, are blocked. There we go, a solution to the chaotic world of running MCP servers and some attempt at securing them from the experts in containerization. Let me know what you think in the comments down below, subscribe, and as always, see you in the next one.